Okay, section 15.2 is all about constructions again. Some different constructions this time. I may not even get around to doing some questions, but I like the demonstrations they give in the introduction. So one thing you must be able to do is to construct accurately an equilateral triangle. Now you should remember from Key Stage 3, equilateral triangles look a bit like that. All the sides are the same and all the angles are 60 degrees. You and you and you. So essentially that is a 60-degree angle, there and there. Equilateral. Same lengths, same angles. 3 equal lengths, 3 equal angles. Now, constructing it is really easy. Supposing they want to make the base, I don't know, 10 centimeters. I won't get the ruler out again. I'm just going to draw a 10 centimeter line just by guesswork. This is what I do. Draw plenty of line there and then do some markings. So I know from there to there, for example, is 10 centimeters. Alright? So from that position to that position, okay? Now, what you do, you take your compass point right there and open it out so that the compass point is there and the pencil stretches all the way to this side. So effectively, you have a 10 centimeter radius. Alright, from there to there. Alright, oops, arrow's in the wrong place. From there to there. Alright, so if you put your compass needle on this side, you'll end up with a compass pointing this direction, and you just swing it round like that, and that will give you a 10 centimeter radius, producing an arc of radius 10 centimeters. Alright, you then take your compass point and put it on the other place and swing in the opposite direction, and what that would do is to give you an arc also of radius 10 centimeters, and this one also has a radius of 10 centimeters. So you can imagine we've got a 10 along the base, a 10 reaching the point of intersection, and a 10 coming back down. Well, 10, 10, 10, that's 3 equal lengths. Therefore the angles will be 60, 60, 60. You've just skillfully constructed an equilateral triangle. So that goes to the point of intersection, and this comes back down. I have to say it looks very isosceles. Never you mind. If you listen to what I've said in the instructional video, you will in fact produce a very accurate equilateral triangle. All lengths will be 10 because you're putting the compass point there and the pencil, and then you're swinging round. Then you're putting the compass point here and swinging round to the left. The arcs overlap. Don't rub them out, you leave them. Both arcs will have a radius of 10 centimeters, and so 3 tens, therefore that equals that equals that equilateral triangle, and you can guarantee therefore with 3 equal lengths you're going to have 3 equal angles. Therefore you have to be a set of 60s, 3 60s, 180, and you've just constructed an equilateral triangle. Right, let me try and bisect a line for you. By that I mean I need to take this compass next door and copy it, because I'm going to be needing to demonstrate how to do that as well. There she is, wonderful compass. So imagine you have a straight line. Here it is, a lovely straight line like so, and I want to bisect it. That means cut it exactly in half in such a way that the line that passes through the middle of it will cut it not just in half but also at 90 degrees as well. Now how do you do that? Simple. You need one of these compasses. Now same sort of thing. If you want to use this compass to construct the perpendicular bisector of this line, oops, I accidentally drew on that, go away. I need to put my compass needle right there, but make sure when I open it up in this direction it'll be over halfway. Alright, over halfway for sure. So if that is, for example, a 10 centimeter line, make sure this opens to well over 5 centimeters. If you don't, the arcs we're about to produce will not overlap and it won't work. So, for example, E.g., if the line is 10 centimeters, then open out to at least 6 centimeters. All right. So this is me. So imagine I've got my pen, I've got my compass point there, and my pencil resting about here, clearly well over halfway. I then raise my compass and draw an arc all the way around through the line like so. All right. So compass there, compass needle there, point there, just whoosh all the way around. Then, without changing the radius of the compass, put the point on this side and swing round to the left, anti-clockwise rather, all the way around. Look at this freehand picture. Bam, there it is. Now what do you see? I see a point of intersection there and a point of intersection there. Now, using my line facility, I'm now going to join those 2 points of intersection as best I can. Now even that, with my crude freehand diagram, looks pretty good. Look, I've pretty much cut it in half. Look at it, that's roughly half each side, and it even looks like it's been cut 90 degrees. Now let me label some stuff for you. This is the line itself, not very technical. This is 90 degrees. This is called a bisector. Bisector, listen to it, cuts in half. Bisector, and it's at 90 degrees to the line I've just cut in half, and therefore it's called perpendicular. Getting glitchy. Oh, come on, not now. The perpendicular bisector. Alright, that's best as undo. So this is a perpendicular bisector. It's a line that cuts another line in half and at 90 degrees as well. And that's how you construct a perpendicular bisector. Alright, now the next part is really exciting. Well, this is my favourite skill, this, and I've never demonstrated it on a screen before using a graphics tablet, but I'm going to have a jolly good go, as I won't be able to teach it. So look, imagine you're given an angle to bisect. So imagine I've got to cut this angle in half using only a pair of compasses. So here is my angle. Let's try and get it so it lands properly. Right, that's alright. Now I've got to cut this in half. I'm not allowed to use a pair of compasses. Sorry, I'm not allowed to use a protractor. The only thing I'm allowed to use is a pair of compasses. So this is what I do. I take this compass here and I put this point right there first of all. I then open it out just a little way, and remember my point's there, get my pencil going, and then just do this, swing round like so. Now by swinging round, I therefore have two equal lines of equal length. Alright, don't worry about the inaccuracy of my freehand drawing. I'm doing the best I can. I've established therefore by whooshing round with this arc, I've cut it there and there with my pencil. I've cut through, and these two lines are the same length. Now put your compass point there and swing, whoosh. Alright, put the compass point there and let the pencil swing round. Then you put your compass point on this side and let it swing round again like so, and the two arcs will overlap, and where they overlap hopefully would allow us to draw the bisector of this angle. Now again, look at it, even on screen with a graphics tablet, it doesn't always behave itself, and me with a shaky hand, I've cut that angle in half pretty well. Look at it. Do you agree? Well, I'm not going to be biased now. Does that look, in terms of an angle, half the whole thing? Do they look roughly the same to you? They do to me. So I have just bisected this angle. I've bisected an angle. That's what I've done. And this is called not a perpendicular bisector because it doesn't cut it in 90 degrees. It's just called a bisector. Cutting an angle in half. And that's absolutely beautiful. I'm dead chuffed about that. I was not looking forward to this part at all because it's really tricky. Right, so I've bisected an angle in half. And when I get to 15.2 proper, we'll do a couple of questions maybe to show how this actually works. And that's it. See you soon.